High-rise buildings rise from the ground. Pile foundation as the main foundation form for bridge structure. The construction quality is of great significance in ensuring the overall safety of the bridge. This section first introduces pile classification, common defect types in cast-in-place piles and their causes. Pile classification includes pile body material types, function of piles, pile formation technology, form of pile-soil interaction. Below, we will explain one by one types of pile body materials: wooden pile, concrete pile, steel pile, pre-stressed pipe pile. Function of piles: compression pile, shear pile, uplift pile, pile formation technology, precast pile, in situ cast pile. Form of pile-soil interaction: friction pile, end-bearing pile, end-bearing friction pile, friction end-bearing pile. Classification by pile construction method: precast pile, prefabricated pile body, striking, vibration, or static pressure methods, driven into the stratum to the design elevation. In situ cast pile, after drilling the pouring hole at the pile location and then pouring. Hole drilling method: driven cast in place pile, seamless steel pipe used as pile pipe. Use a drop hammer or vibration hammer to, after driving into the soil layer to the bearing stratum at the design depth. Then pour concrete, hammering or vibrating while pulling the pipe during pouring, until final pile formation. Drilled impact cast-in-place pile, mechanically drilled hole, slurry wall protection, placement of the reinforcement cage, pouring concrete, manually excavated cast-in-place pile, manually drilled hole, brick lining or no lining, placement of the reinforcement cage, short and thick pile. Other modes: board cast-in-place piles are a common foundation pile type. Its characteristic is high bearing capacity, uniform settlement, large horizontal load, good seismic resistance, but the construction process is difficult to control. Slow velocity, long construction period, prone to quality issues. Next, we take board cast-in-place piles as an example. Analyze their common defect types and causes. Underwater pouring, broken pile, full section mud or sand inclusion. When pouring concrete, the lower end of the conduit leaves the concrete surface. Or discontinuous pouring, localized necking or soil inclusion in the cross-section. Improper slurry density configuration, loose strata, collapse of borehole walls or similar occurrences. Separation, dispersed mud lumps, cellular concrete, concentrated air voids, uneven concrete mixing, excessive water-cement ratio, water leakage in conduits, etc. Pile bottom sediment, excessive pile bottom sediment and mudcake on the whole wall, causing significant reduction in bearing capacity. Post-cleaning sediment thickness requirement for end-bearing piles is less than or equal to 50 mm. Friction pile is less than or equal to 300 mm. Friction end-bearing and end-bearing friction pile is less than or equal to 100 mm. Low strength zone in pile head concrete, caused by factors such as slurry floating, reinforcement cage misalignment, floating or leaning against the hole wall. Dry hole pouring. After hole formation, concrete is delivered to the pouring surface via a hoist or chute. Layered segregation or broken pile. Groundwater influx into the hole causing segregation. Layered accumulation of sand and gravel. Poor stratum stability causing hole collapse. Formation of a broken pile. Local mud inclusion or honeycombing. Leakage of mud water into the hole wall casing or insufficient vibration. Severe local segregation. Improper injection height. Pile bottom sediment. Excessive loose soil at pile bottom. Incomplete hole cleaning. Pile integrity is the main indicator of cast-in-place pile quality. Pile body completeness. Uneven pile body concrete quality. Defects such as cross-sectional fracture or those affecting the load-bearing area. And defects leading to exposed rebar, etc. Foundation pile bearing capacity. Difficult to measure accurately with non-destructive methods. Piles with qualified integrity generally meet bearing capacity requirements. Foundation pile durability. No obvious corrosive medium underground. And when the pile body is intact, the durability is good. Probability of unqualified integrity is higher than probability of bearing capacity failure. As long as the integrity is qualified, bearing capacity is generally qualified. However, if bearing capacity is qualified, the integrity is not necessarily qualified, and durability is not necessarily qualified. Pile integrity is the main indicator of cast-in-place pile quality. In this lesson, we mainly studied classification of foundation piles, defect types of board cast-in-place piles, defect causes of board cast-in-place piles. Through the learning, hope you in future work processes can distinguish the category of pile, understanding the defect types and causes of pile foundations, facing engineering problems, diligent in thinking, identify the cause, continuously improve professional quality and expertise. After class, please consider the following questions. Why conduct engineering inspection on bridge foundation piles?